As our final topic for our user-defined functions series, we're going to look at how to look at function source code, not just what we have written, but what others have written, and how we may be able to modify or add to it in order to enhance the function for our purposes. Sometimes we want to view the code for functions we wrote to understand why it may not be doing what we anticipated, or to consider improving or adding to our function. We can do this without going to the source file. We can also look at the functions written by others, including base R functions, to see how they work. This might give us insights for our own script writing. We also may want to copy functions so we can change or add to it. Students in a past non-parametric course of mine will remember the time when I was using a base R function and not getting the results I thought we should be getting. I was demonstrating how it worked, telling what we should get, and was getting something different. So right there in class, we looked together at the function and we found an error. We were able to copy the code, change the error, correct it, make our own function that would do the same thing, except without the error in it. I have yet to notify anyone from the core R team of this error, so it still sits there, but perhaps one day I'll do it. We can view the code for a function by using the function name. In a previous video, I defined the square plus function. So if I click on square plus, the name itself, it will give us what that function says. We can also do this to look at other functions, including those in base R, like the t-test. Now this tells us it's going to send all of our parameters to a particular t-test method. Note, use method t-test. Let's see what methods there are for the t-test. There's t-test default and t-test formula. So let's try looking at the default t-test method. It says it's not found. Only t-test is loaded into our environment. Only t-test is what we're given access to, not t-test default. Notice that if we use t-test, it will actually send our parameters, it will pass them through, see the three dots in the function? It will pass them through to the t-test default function. But t-test default is currently not in our environment. T-test default is in the stats package. Now the stats package is installed in R when you install base R. There are a few packages that are installed along with base R, and stats package is one of them. So t-test default is in there somewhere. It's just not in our current environment. Let's see if we can actually export it from the stats package. The operator I'm using, double colon, is to export from a package. It is not an exported object. What does that even mean, an exported object? Well, some packages will allow you to export a function in that package for your use outside of the package. Other objects are internal to the package. They can only be run within the package, and t-test default is one of those. Why is that? That's because what we have access to is t-test. T-test is the only thing the user should see. And then t-test will actually call from within the stats package to run t-test default. So it's a little bit technical, I know, but an exported object is one that the package says, we have a function in this package that you can go ahead and use. so-called imports are internal to the package. So they're mainly for doing the behind-the-scenes work, and the t-test default is doing the behind-the-scenes work. But that's what I want to see. I want to see the t-test default and what the behind-the-scenes work is. So now we have another operator we can use. The double colon was to see if it was a function that we could bring in to look at. The triple colon can be used for functions that are internal to a package. So I'm going to use the triple colon operator, and now it will let me look at t-test default, and there it is. So if you want to see what the t-test script is, there it is. You can look at it, and some Saturday night when you have very little to do, I recommend you go ahead and look at this and see if you can work through it bit by bit by bit. Take a look at the code and walk through every line and see exactly how it works. Wouldn't that be just a fabulous Saturday night activity? Now, there's also a function in R that keeps us from having to check whether the function can be exported or if it's internal to the package, and that's the get anywhere. With get anywhere, it will say if it's an import function, I want to grab it from wherever it is. If it's an exportable function, then we'll look at it within our own environment. So get anywhere will also give us the information for t-test default. Okay, so I just demonstrated how to look at a particular function. Here's one that's available to us right in our environment, SD. And in fact, we can see what SD does. Look at this. It takes the square root of variance. That's all it does. Well, then we probably ought to look at the variance function to see what it does. Let's look. This is the variance function. And if we look through here a bit, we'll see in the variance function that once it determines what to do with all the arguments that it is sent, which is up here, then it comes down, and here's the heart of it right here. The heart of it is that it's going to call the covariance function. Well, variance, of course, is simply the covariance of a variable with itself. And so it makes sense that it's calling the covariance function. Note that the function is CCOV, and note the call is .call. This tells me that it is compiled code. If I want to see the source, I'm not going to be able to see it here. I'm going to have to actually do some research on the web to try to see the source. Compiled code is code that was written in a script and then turned into computer language, what we call machine language. So we actually would not see our scripts. We would not see words if we were to look at the code. All we'd see is a bunch of binary numbers that would be telling the computer what to do. I'm not going to go do a web search to look at that compiled code. I'm just showing you how to look at the primary scripts. But what you do need to keep in mind is whenever you see these things like .call, that means you're not going to be able to look at some R script. Let's look at an example of how we can use source code to do what we want to do. I'm going to use the Tukey HSD function. So I'm going to read in some data. I want to make sure that my here library has already been loaded. It has been. And so I'm going to read in this data, HSB2. I'm going to turn SES into a factor. I'm going to create a model in which I model math scores as a function of the factor SES, so I'm doing basically one factor ANOVA. I'm going to take the results from the Tukey HSD model and I'm going to plot those results. Let's take a look at what we get. We get 3 Tukey confidence intervals. So these are controlling for our overall error rate for all 3 intervals. Here is an interval looking at high SES math scores minus middle SES math score and looking at the mean difference of those. Here we're looking at the mean for high SES and low SES, and here we're looking at the mean for middle and low. But notice the title. That's not a very good title to my plot. 95% family-wise confidence interval. It's informative, but I don't like it as a title to my plot. So let's go back up and see what we can do. Let me look at the methods for plot. The methods for plot include a plot Tukey HSD. So that's what's actually creating this plot. Let's go ahead and get anywhere, plot HSD, here it is. So I've taken and cut and pasted it right here so that we could look it over. What if we do the following? What if we take this and put in a title here? Notice the title. Okay, the title is confidence level percent family-wise confidence. What if I create a new function, and I'm going to do it. I'm not going to just say what if, I'm actually going to do it. And I'm going to call it new plot Tukey HSD, and I'm going to copy everything. So I'm copying everything from up above, except that I'm going to add one argument. And the one argument is going to be new title. So notice that everything from line 597 down to 622, which is the plot Tukey HSD function, I'm copied right here, except I did a couple little changes. I put in a new argument called new title, and then down here for title, I put in new title for my main instead of the one that used to be there. Now, let's go ahead and load this function. And now let's try it with my new plot Tukey HSD, my results, and I'm going to give a new title, Tukey confidence intervals. And there you go. So what we have done is we have taken advantage of existing code that's written right into base R, modified it to make it do something that seemed to us a nicer way to output those confidence intervals and a nicer way to title this plot. The source code of many functions can be viewed by entering the function name. The methods function can be used to determine if there are various forms of a function. And we have some operators for accessing functions that we can't call up just by their name because they're not loaded in. The double colon will access a function within a package that the package allows us to export that. But if it can't be exported, the triple colon will access the function within that package. And we can avoid using either of these if we want to use the getAnywhere function to find that function and bring it in to our environment. Functions that use .c, .call, .fortran, .external, .internal, or .primitive are calling code that is already compiled. We will not be able to see those functions. Why are some pieces of code compiled? Because compiled code runs faster. And so when we're talking about aspects like covariance that are going to be used by thousands and thousands of people many, many, many times for each person, then those are compiled to make them run fast. If we want to see the code, we're going to have to do some web searching. I invite and encourage you to look at code that has been written by the R core team, as well as code that's been written in packages that you can load into R It's a great way to learn. And don't hesitate if you see something in a function not behaving the way you wish it would behave. Don't hesitate to just copy that function into a new object and fiddle with it. You're not going to hurt anything in the original function. You're only going to be working with it within your new object. And if you like the results, you can keep it. If not, you can let it go.